Okay, so let's start today's session. And maybe I can share my screen. I think this is visible. So today I'm not that much well, but yeah, fine. So okay, today we will talk about week six previous year assignment. Actually, this is
Mir kodama.
yes. Someone is telling something. Who is telling something? Ru Rutu. Hello, am I audible or not? Is my voice clear? Yes.
Yeah, yeah,
Okay. Okay, and my screen is visible, right?
yeah. Yes, ma'am.
Okay, okay, fine. Okay, so today is not my scheduled class. My scheduled class is on Friday, but due to some problem, I just rescheduled that class to Monday. Okay, fine. So today we will talk about week six previous year assignment questions. So basically, previous year assignment question for week six. If you see that one, then there is only four quiz. There is no problem. I mean, programming solve like thing. There is nothing. So only there is four questions as a quiz, and I think the last date of that submission is like 5th March or 3rd March, like that. I don't remember rightly. But the thing is, only there are four questions, and these four questions are based on the topic, based on the lectures, whatever sir was giving on that week six lecture. There were five lectures, and in that five lectures, most of the lectures were covered like heap, then sets, then there was like stacks and all these things. And the main thing is that the assignment questions are coming from only sets and heap. Okay. Sorry. So what we will do today, we will just do a recap of set and heap, and after that we will go directly to the previous year questions. Actually, as there were only four questions for the previous year, so what I did, I just found the previous to previous year questions, and previous to previous year questions as well. There was four questions, right? And among these four questions, one is common for this previous year question. So as a whole, I have the seven questions right now with me. So let's talk about these seven questions. And before going to there, we just want to have a recap of that shade and heap. Okay. So so what is set? Actually, I did not write here anything because maybe I can write with my pen. Uh, so what is set? Set obviously we know in mathematics, but set in Python we are talking, right? Of Today we will talk about set in Python. So and how it is working. Set in Python, right? So what is set in Python? It is exactly same, and it has the exactly same behavior as the mathematics set. So for mathematics set is what? Set is nothing but a list of numbers, or list of like, let's say let's of some strings or something. But in the Python, the set has a different, I mean, a little bit different property. What is the property here? Let's say I am writing here set equals to this is the curly bracket to represent the set in mathematics, that we all know. But in Python, if you just see the previous year lectures as well as previous week lecture, then you can see this. sign is nothing but by default for dictionary, right? And in Python, and this is for tuple, and this is for list. So these things we know, right? So this third bracket is for list, second bracket is for dictionary, first bracket is for tuple. But and also in the mathematics, when we are talking about set, then we are writing some numbers inside the second bracket. But in that case of Python, if I write something inside of the second bracket, then it will consider it as a dictionary. So to get rid of these problems, what we can do, let's say I'm writing here A as a set, like in Python. So how we can write it? So A can be a number of, let's say A is a set of numbers. So for that, we will just write here set, then first bracket, then inside that first bracket, let's say I'm writing some list of numbers. So 1, 2, 3, 4, 5, 6, something. So this is a set, right? So this is a set of numbers. If I will just print, I just want to print the A in a terminal. We will do that one in a minute. So if I just want to print the A in a terminal, then what it will show? It will show within that third bracket 1, 2, 3, 4, 5, 6. So what does this mean? This means that right now A is nothing but a set. This is not a dictionary right now, as I have already mentioned it as set and then these things. So it will just make a set. Even also I can write it like set, then first bracket, and then inside that first bracket I can write it in the second bracket as well. 1, 2, 3, 4, 5, 6. This is the exactly same whatever it was previously, right? So we will see in a minute side by side so that it will be clear. So I'm just having the idle cell as all of you know. So maybe writing here I can first write A, A then set. So as I told you, we have to mention that it is a set. Otherwise, it will not understand that A is a set in our Python language. So let's say I'm writing here. Sorry, 1, 2, 3, 4, 5, 6. So this is just a set of numbers. So if I just write here, then I just want to print here A. What is A? Right now you can see this is within the second bracket. So that means whatever the mathematical representation in the simple mathematics set, that is exactly reflecting here. If I just put A equals to set of list of numbers. So now you can see, okay, one more property of that set is like, let's say I am right now here, set is 3, 4, 5, 6, 7, 3, 4, 5, 6. Oh, anything, like you can write anything. So what I have done, I have just mentioned here 3 twice, 4 twice, 5 twice, 6 twice. So now if I just run this one and if I just want to have the value of A, so what it is showing? It is showing that only once these duplicate numbers. Okay. So like here you can see A was 3, 4, 5, 6, 7, 3, 4, 5, 6. But now when I just want to print the value of A, they only will take the ones in a value. Like they will not repeat these duplicate numbers. They will just remove the duplicate numbers from the set. This is a property in the set in Python. So one property is that whenever we have to write something as a set, we have to clearly mention that set, then first bracket, and within that first bracket, whatever we want as a set, that should be mentioned. So this is the first property. And the second property is, if inside the set there is a duplicate numbers or duplicate strings, that will be removed by that set. I will show you another example. Let's say I can write here some string. Okay. So in that string, let's say I am having a random number. Okay, not random. If you just see the known number, then it will be good. Let's say I am having pen, sil, box, pen. Okay, okay, at the very first, pencil box. Just see pencil box. So if I see right here, B equals to set of string of pencil box, then what it will print? It will print each and every word of this, each and every letter of this word individually. Okay, so that it will show, it will take this pencilbox everything as a individual letter, individual string. But to be mentioned here, you can see the pencil box. If I write here, then P should be at the very first, E should be at, in this next, N should be at the next. But we can see that there is no ordering of that. It is just like a randomization. See here, B is first, then L is first, L is second, E is second, O is second. Like this is just a randomness. So this is also a property of this set, that whenever we will just have a value, even here also you can see. Okay, for the numbers as well, if I just see right here, set, let's say 4, 5, 3, 2, 3, 2, 3. So this is a random number. Oh, it is a, right. I have to write it like within which I just want to write here. So it should be within a list. So if I will write like that, then if I just want to print here A1, then you can see 4, 5, 3, 2, 3, 2, 3. So what it should be? It should be 4, 5, 3, 2, because I already told that it will remove all the duplicates. But the thing is, it will suffer, it will shuffle, and it will just do in a ordered manner. 2, 3, 4, 5. At the very first 2, then 3, then 4, and then 5. So ordering is little bit randomization for this set, but the thing is, it will just remove all the duplicate things from this shade. I mean, from the list of the numbers, or from the list of this, I mean, from the string as well. So let me write here another example. So let's say I'm writing here B1, and let's say I'm just changing this one as papaya. Okay, now you can see here P is twice, A is thrice, and Y is once. So if I want to write the value of B1 in terms of set, then what it will be? It will be only A, Y, and P. It is just going to remove all the duplicates. Okay, another more thing is that if I just want to write here what is the type of B1, to make sure that whatever we are doing, that is exactly correct. So if I just write here type of B1, it should say a set. See, it is coming as class of set. So that means whatever we are talking, that B1 is a set, that is exactly correct by typing that one as set. Okay, the type of B1 is class of set. Okay, so this is a little bit talking about set. Now coming to the operation of the set, because this is most important thing for our assignment. So set operations. So how many operations are there for set? Let's say one, I am having one set operation. Let's say at the very first I am having A and B. So for the completeness, I just want to give you one example of A and B. Sorry. So let's say I am having A as a set. In mathematical representation, I am writing like that. But for Python, I have to write here set, and then first bracket, open and close, and inside of that list of numbers that you understand already. So if I write here 5, 6, 7, 9, 20, we will just do all these operations with the example itself, so that it will be clear. So for B, it is 9, 8, then 4, 5, 20. It's a random A and B numbers. Okay. So first set operation. First operation is union. It is exactly similar as mathematics, because in mathematics set operation also we are having four type of operations. One is union, then intersect, then there is intersection, then there is a set difference, and there is a exclusive or. These four will be exactly worked for our Python, I mean work for our set in Python as well. So how it will work for the union case? Let me write here. Union case by it will be represented by A and this shine and then B. You can see in your keyboard as well, you can see this type of shine. So this is representing the A union B. So as mathematics has a property that what if there is A and B as a set, then what will be the union of A and B? Then the in mathematics how it is representing, it is representing like that. But in mathematics, I mean in Python, I have to write it in a form so that our Python interpreter can understand. So to understand the Python interpreter symbol, this is the symbol for the union case in Python. And what will be the result for this case as A union B? Union is nothing but we are having all the common factors of A and B first, and the remaining terms also we will just write. So for this case, you can see what are the common factors. Five are common. Okay, let me write here common factors, common numbers. Common numbers are 5. Then you can see here 20. These two are the common numbers. So if I just write here A intersection union B, then what will be there? Then 5 will be there. Then 20 will also be there, and other things which is present in A and B, that all will come. So it is like 6, 7, 9. Oh, 9 is also common here. Okay. Then 8, then 4, like that. So let me just write here side by side. So let's say I am having A equals to set of list of numbers, and the list of numbers are like, let's say 5, 6, 7, 9, 20. So this is one set, and then B equals to set of, it is like 9, 8, 4, 5, 20. Okay, so these are the numbers. So now if I just want to write here A union B, so what will be the value? A union B. At the very first what we told, see here the terms 4, 5, then 6, 7, 8, 9 and 20. So all the terms are there. So that means what? Whatever the common factor was there, common factor was 5, 9 and 20. That should be there, 5, 9 and 20. Other than that one, whatever the remaining terms were there for A and B, that will also be present in A union B set. Okay, now coming to intersection. So for intersection, the notation is like A and B. Okay, this is like A and B. So intersection is what? For intersection case, we need to take the common factors only, common numbers only. So for this case, what will be the intersection of A and B? This will be simply 5, 9, 20. Let's check that one with the help of our ideal interpreter, A and B. So this is, you can see 9, 20 and 5. As I already told that the order does not matter here for this case of set in Python. So obviously it will give a different set, I mean different order. Now coming here the third option. Third option is their set difference. Sir has already told these things, but to make sure that we will just recap these things so that we can have the answer of that assignments very clearly. So A minus B, this is the set difference. So what does this means? This means at the very first, maybe I can write here A minus B. Okay, so what does this means? This means that the terms of A which are not present in B. Now come here. There are belongs in A. Among these, 9, 5 and 20 are present in B. So remaining terms 6 and 7, these are giving us A minus B. So I can write a statement here. What is the set difference? Means A minus B, elements of A which are not present in B. Okay. And obviously by seeing the set difference, you can see B minus A is not equals to A minus B. Yes. Because what is B minus A? B minus A will be like elements of B which are not present in A. Elements of B which are not present in A. Now you can see for this example, if I have A minus B, then what it will give? Elements of A which are not present in B. Okay. Am I audible? I think. Yes. Yes?
Yes, ma'am.
Okay. I was thinking that my internet has already. Okay, so common, yeah, what I was talking, A minus B, that means the elements of A which are not present in B. So in this case of this example, A has 5 elements, and among these 5 elements, 3 elements are common. So this 6 and 7 will give us A minus B. Now coming to B minus A. B minus A means the number of element present in B but not present in A. So now see, there is again 5 numbers, but among these 5 numbers 9, 5 and 20 are present in A. So other 8 and 4. This will give us B minus A. Just check if I am correct or not. B minus A, 8 and 4. Okay. Okay, so this is third operation, and now the fourth operation. It is exclusive OR. And exclusive OR is denoted as like A to the power. You can see in that books there is a one to the power sign is there. So A to the power B. So what is the meaning of that? Means I am writing here A to the first what? 6, 7, 9, 20, and 9, 3, 4, 5, 20. Okay. So A to the power B. Just first do this one here. A to the power B. See, 4, 7, 6, 8. Let me write here first. A to the power B is 4, 7, 6, 8. So what is 4, 7, 6, 8 means? Like A, B, what are the common factors? Just write here common factors. I just write here previously as well. Common elements. Common elements was 5, 9 and 20. So A to the power B, that means exclusive OR of A and B set are nothing but the elements of A and B which are not common for A and B set. So here we can see for A and B set the common factor numbers are, oh, not 6. Common factors are 5, 9 and 20. 9, 5 and 20. So we will just remove these common factors and any other numbers, what is 6, 7, 8, 4. These four numbers will come as exclusive OR, a to the power b. Okay, so a to the power b is nothing but, if I just write here in sorry, language, a to the power b is the elements of set a and set b which are not common to a and b. Now, oh, internet is there still? Ah, okay, fine. Oh, hello? Hello, can you hear me?
Yes, ma'am.
My screen is visible? No, na? Can you see my screen? No?
No, ma'am.
Okay, okay. Oh, now it is coming. Okay, just a minute. Actually, internet has gone, so that's yeah. Now you can see my screen. Okay. So, what we were talking about exclusive OR, that is a to the power b, which is nothing but the elements of the set A and set B, which are not common to A and B. Okay. So these are the four set operations we will talk about right now when we will talk about the assignments. So up to this, I mean, obviously this is a very simple thing in mathematics as a set. So is there any problem? Is there any comment? Is there anything regarding this set in Python so that we can move forward, or otherwise you can have some discussion, then you can. Do you have any question regarding these four set operations? Okay.
No, ma'am.
If not, then we can go directly to the question and we will talk a little bit more on heap, but it will be little bit later. Just solve at the very first about the questions on set. Okay. So this is the, oh, don't see the option. So there is,
Hello, ma'am.
yes.
Ma'am, can you solve an queen problem?
Can we solve the
An queen problem.
which problem?
In a assignment number in a one video, an queen problem are shown.
Sorry, I can't hear you properly. Can you tell a little bit loud?
In a video lecture, one and queen problem are not easily to understand. It's a bunch of program.
8 queen problem.
N queen problem.
N queen
8 queen
problem.
are arranged in the chessboard.
N queen problem you are talking. Okay, okay. Okay, we will do that one because that is the main thing I think in the first class, yes, first class of the week 7 lecture, sir was discussing that one. And not in the first class, in the second class, I mean, second lecture as well, he was discussing that 8 queen problem. I mean, 8 queen and n queen. I mean, it will, if you just generalize that one, then it will be n queen. But yeah, okay, we will do that one. But the thing is that at the very first, we can just solve these things because it's a very simple one. So after completing this one, we will go for the n queen problem. Okay, but I don't know that I mean the problem and the programming is with me or not, but I have to check that one. Or otherwise I can just frame you that what is the problem there and what we are going to do there. That I can do in a simple language maybe. Okay, but just before that we just have a little bit look here, because we are just here to solve the previous year questions at the very first, and after that whatever will be the problem for the students, that we will discuss, no problem on that. So suppose u and v both have values of type set and are disjoint. So disjoint means what? What does this mean, sir, by disjoint? Disjoint means there is no elements common for u and v. So if I write here u and v intersection, that should be a null set, not zero here, without anything. Okay, this is a null set. So disjoint means u and v does not have common element. Okay, this is the case for u and v. Okay, I mean u and v both are disjoint. Which of the following expressions evaluates to true? So let's say with the example we will just discuss these things. Let's say I am having here 1 2 3 and 4, and v is like 5 6 7 8. It's very simple example because they both are disjoint and there is no common factor in between u and v. So now you can see at the very first it is saying that u equals to v, this is union, and then u to the power v, that means exclusive or of u and v. So first we will have the u exclusive v. So u exclusive v will have the value. Can you tell me what will be the value for u to the power v for this case? 1 2 3 4 5 6 7 8.
Will be a null.
Sorry, can you tell me what will be the value of u to the power v, that means exclusive or of u and v set for this example? See, u and v is nothing. U to the power v is nothing but the all the elements of u and v other than the common elements in u and v. So here you can see that there is
So
no common element in u and v. Why? Because these two are disjoint. Okay. So for that case, 1, 2, 3, 4, 5, 6, 7, 8 all will be there for u to the power v. Now v union u to the power v. So what will be v union u to the power v? It will be exactly same as 1, 2, 3, 4, 5, 6, 7, 8. Why? Because v and then union they are talking about, and then exclusive or. So that means there will be a union of v and u to the power v. So v is this 5 6 7 and 8, and u to the power v is 1 2 3 4 5 6 7 8. So as a whole union will be exactly same as 1 2 3 4 5 6 7 8. So this is nothing but u to the power v, but they are saying that u is equal to this one, so that means it is not correct. Okay, now coming to u is equals to v to the power u. I mean v to the power u means v and u exclusive or. So what v and u exclusive or? V and u exclusive or is exactly same as u and v exclusive or for this case. Okay. So if it is true, then you can see that we are having already the v and u exclusive or, which is not equals to u. because in U 1, 2, 3, 4 is only there, but here the other things are also there, so this is not equals to U. So this is also not correct. Now coming to the third option, U equals to V exclusive or U and V. Okay, so now at the very first, U and V union I will have. So what will be U and V union? The union will be like 1, 2, 3, 4, 5, 6, 7, 8. Okay, these are the U union V. Now V to the power U union V. V to the power U union V means, as we already told, that all the elements of V as well as these which are not equal to, I mean which are not common in both the set. So there are how many common factors are there? Common factor means 5, 6, 7, 8. All the are the common factors for these two set. So U to the power V, U union V, that will give us 1, 2, 3, 4. Okay. So now you can see that this is equal to U. So this option is correct. You can see the last option as well, and it will also not give the actual value. See, for this case U union V and V union U is exactly same, so I can write it like that also. And U to the power V and U to the power V and U means the all other elements other than these common factors of 1, 2, 3, 4. So what will be the value if I write here U to the power V and U in the next last option? So it will come as 5, 6, 7, 8. So this is not equal because this is also not equals to U. I think it's understandable. Yeah, so option 3 is the correct one. Okay, so quickly we can go for the not heap question. Yes, this one. Suppose U and V both denotes sets in Python. Okay, so U and V, they are the same. What is the most general condition that guarantees that U minus V minus U is equals to U? So first option, let me check that sets U and V should be disjoint. So again, this example 1, 2, only 1, 2 and 3, 4, that is also fine. Okay, very simple example. So if it is 1, 2 and 3, 4, then V minus U. What is minus here? Difference. I have already mentioned here what is minus stands for. You can see set difference. Yes, here. Yes. A minus B or B minus A. What is this one? Elements of A which are not present in B. Elements of A which are not present in B. So elements of V which is not present in U. So element of V 3 and 4. These two are not present in U because both are adjoint matrix, disjoint matrix. So V minus U is 3 and 4, which is V. Now U minus V minus U. That means the element of U which are not present in this set V minus U. So V minus U has the set element as 3 and 4, and U has a set element as 1 and 2. So what will be the value for U minus V minus U? That will be simply 1 and 2, because the elements are in U which are not present in that element of 3 and 4. So this is 1 and 2. So now see, this is exactly same as U 1, 2. So this condition is satisfied. For this case, the sets U and V should be disjoint. And it is true for every big or small set. So maybe we can have a little bit more calculation. Like, let's say I am writing here 4, 5, 6, 7, 8, 3, 83, 5. then V 1 2 0 9. Why? Because both are disjoint. So this is U and V. Now what they wanted to know? They wanted to know V, no, U minus V minus U. So what will be the result? You can see here the result is 4 5 6 7 83. That means U. Okay. So the first option is correct. Now we can just check for our confirmation that whether these 4 options are true or not. Like these are wrong or not. So the set V should be a subset of U. What is the meaning of subset? So if I have, let's say, U equals to 1 2 3 and V is, let's say, 4 5. This means all the terms of V are present in U. This is a subset of U. So V is a subset of U. The set V should be a subset of U. If this is the condition, I mean if this is the case, then they are telling that this should be true. Just check this is true or not. So V minus U. So V minus U will be what? For this case, it will be null vector. I mean, null vector means null set means only like that. Why? Because no. Sorry. Yeah, V minus U is null because V means what? The element of this matrix which is not present, which are not common in with this. So there is only two terms and it is already putting as a common one. So it will give us a simply null set. So now U minus null set. So U minus null set means U will be there. U means as a whole these things and one null set. And one more thing is that in if it is there, then there will be another null set is also there. So null set will also be a common factor. So it will not give. I can tell you this one. Let's say I am writing here U equals to set, not V, U. 3 4 5 6 7 8 and V is set of 6 7, then U minus V minus U. 3 4 5 6 7 8. Yeah, that is also true because right, you can see here V minus U is set null because there is no other than common factors. But U minus V minus U, that will give us a result which is exactly U. So that is also true. Why that is true? Because we have already seen that this is also guarantees that this. Now why it is guarantees tails? So you can have a look of these things. What is a subset and proper subset? Proper subset, what I am right now telling here, that 4 5 which are the exactly subset, proper subset. But the thing is that it is not always guarantees this will be equals to U. One example can be like that it is 4 5 and then 7 8. Yeah, wait. Yes. So the thing is that if you just do these things, that only this option will be correct, and obviously this is true for any U and V that is not correct. Because if I have one example as like u 1 2 3 4, and then v is like 3 2 8 9, like that. So it will be like v minus u. V minus u means it will come as 8 and 9. But like u v minus u, u, all the elements of u which is not present in v minus u. Oh, that is also coming as u. Let me see, because this is not true for u and v. U minus v minus u. V minus u is always, let me see, u equals to shade of 7 8 6 5 4 3 6. So u minus v minus u. 4 5. Yeah, it should be, all the things will be exactly same. Okay, I think there is a problem in that question. Most general condition that guarantees that this. Guarantees this means obviously it will also be there, right? Okay, I will see this question, because this question is giving a little bit confusion, that all the options are coming as a true. Okay, as you can see here, we were just seeing that if it is a disjoint, that is also true. If it is true for any u and v, that is also coming as true. So maybe we will think a little bit for this question, and we will have a answer in the next class, because all the options are coming as true. Okay. Okay, fine. Just come here so that we can go on time. Suppose even v both denote sets in Python, what is the most general condition that guarantees that these things? Okay, this is again the similar thing. Just see that one by your own, and you can see that only I can write here that this should be equal to the disjoint one, because for other case it will not be correct. Like you can see here, the similar thing is there. Let's say u is 1 2 3 4, and v is, let's say, 3 4. So what is u to the power v? U to the power v is nothing but what it was there. Let's say I'm writing here set 1 2 3 4. Now let's say I'm writing here 3 4. So it is like, what was there, u to the power v, u to the power v, that means exclusive or. So exclusive or is, you can see here, 1 and 2 are there. So why? Because the terms of u which are not present in this common factor. So 1 and 2 are the common factor, it is not present in the common factor, so u to the power v is giving us 1 and 2. Now you can see here, this is the union. Union means what? All the terms containing these common factors as well. So u common factor v, that is giving us 1 2 3 4. So these two will not be the correct one, I mean these two will not be the same. So this is fine. Now coming here as a set, subset is also this one na? U has a 1 2 3 4. V is also a subset of u, because V has the term as 3 and 4. So this is also wrong, like, because you can see here the same option is given, which is showing that u to the power v is not equals to u union v. But if I write here u and v, both are disjoint. So let's say I'm writing here both are disjoint. Disjoint means there is no common factor between these things. 1 2 3 4 5, and another one is like v equals to shade of sorry 9 0. Okay. So now you can see v to the, no, u to the power v. Okay. U to the power v, this is a u to the power v means, okay, u, the set of u and v which are not present in the common one. So now u u sorry of u union v, that will be same. Why? Because there is no common factor. So common factor, no, there is no common factor means there is nothing for the subtraction in the case of u to the power v. But for the case of similarly for u union v, that is also exactly giving a same answer, that all the common factor including the all the terms in u and v. So u to the power v and u and v will be same for this case of disjoint only. So this is the case for this question number 2. I mean, next question. Okay, now as we will already went for these 3 questions in set, then maybe we can go for the heap a little bit. For heap, sir have already given all these definitions and all the informations. So I just want to mention one thing, that obviously you all know that this is root, and then let's say there is something as a parent. Why it is known as parent? Like because there is one left child and one right child is there. Okay, and then there maybe there is only one person is there, so this is a leaf. So this type of things are there. So now everything this whole circle is nothing but a one node. Okay, so this is representing a node here. Now to be a heap, there is only two condition. One is that it should follow the up down condition. Up down condition means, and another one is left right condition. So up down condition means like the binary tree will go from the up to from up to down, and it should go from left to right. So at the very first it will fill all the things in left, and after that it will come to the right one. So if it is just as an example, if I will see that this, so this is not a heap. Why? Because there should be one node, and after that it will come here, because this is not a left to right condition satisfied. So these type of things are there for heaps. And there is two types of heap. One is mean heap, and another one is max heap. And there is two other terms. One is delete, mean, and another one is insert. So these four the terms is there. So delete means like I have to delete one. Let's say for max heap, I just want to delete the minimum value. Okay, and then for the mean heap, I just want to delete the maximum value. And insert means I just want to insert one uh, node in this heap. So how to do these things, that will be important for our case. So for the case of max heap, max heap, this root, the value of root should be greater than the value of the parents as well as these branches. Okay, so now let's say I am having here 20. So that means for the max heap, these two will be less than 20. Like one is 10, another one is 12. That is fine. Again, for the 10 case, if it has two child, one should be 5, one should be 7, which is less than 10. For 12, if there are two children, that will be like 7, or another is like 2. That is also fine. But this is for the max heap case. But let's say I am having here 20, but I am having here 5 and 7, that is fine. But now for this case I am having, let's say, 10, and here I am having 2. So this is not a max heap, because this condition is a If it is 10, then this is not satisfying the condition of that max heap, so it will not work as a max heap. Okay, so now what is mean heap? Just coming for a simple language. So mean heap is exactly opposite to that max heap. So here that root value will be minimum. Okay, so let's say it is 20, but for this mean heap, these values will be greater than 20. Like let's say it is 21 and this is 80. That is fine. Now here for this case, if every time it will be little bit larger than 21, so it will be 90 and this is 101. This is fine. Now here you can see here 80, for 80 it is like 81 and let's say 82. These two are fine. So this is mean heap. But for this case, if I write here, let's say 20, and then there is like 21, but here we can write here 80, but for here it is like let's say 10. So this will not satisfy the mean heap condition, and this is fine. But here as well, this 81 and 82, these two are fine. So this is the structure for the mean heap, but obviously we have to go always from top to bottom and left to right. So this is the characteristics for heap. So
Hello.
for this heap
Mm-hmm.
case, there is two thing, like one is insert and another one is delete. So insert means we are going to insert one node in our branch, in our binary tree. So let's say let's say we are talking about max heap case. Okay. So for max heap case, what was the meaning of max heap? Max heap means at the very first it will be maximum value, and then there will be like 10, then 12, then there is two left child and right child. So 5 and 2. So and there is like, just a minute. So there is 2 and there is 10, 9. So this is a valid heap for our case. Now I just want to insert another more, or I just, okay, if I just want to insert one node, so this one should be inserted here, because these all are already filled. Now the next one will fill here. So to have the value of here, let's say I just want to insert 19. তোর ল্যাপটপ just a minute please. ল্যাপটপ আছে ও, তোর ওয়াইফাই, ও ওই ওয়াইফাই পাসওয়ার্ড ফর্মুলা, সরি, phd@2019, ঠিক আছে, phd@2019, কি? Hello, sorry. Yeah, so what we were talking, yes. So to insert this, let's say I'm just inserting here 19. So if I just insert here 19, then obviously you can see 5 is not greater than 19. So this will just flip these values. So here the 19 will come and here the 5 will come. Now this condition is satisfied, but for this case 19 is greater than 10. So this is not holding the condition. So this will again flip. So for this case it will be 10 and it will be 19. Now you can see 20 is greater than 19, so that means it is fine. So as a whole, if I just have the case, Yes, so for this case, like 20, then there will be 19. Then these things are exactly same, whatever it was previously, 19. But here it will be 2, and this will come as 10, and this is come as 5. Okay, so just a minute. I think I'm audible. So let me share my screen. Yeah. Yeah, so what we were talking, like if I just want to insert one term, then it will come as like if I want to insert the number 19, I'm audible, right? Yes. So if I want to insert the term, then it will come as this in the final state. Okay. So similarly, if I just want to delete one thing, so if I want to delete means like let's say I am having the same thing as a 20. With the help of question, maybe it will be little bit clear. So maybe we can go directly to the question, and after that we will show something about that 8 queen problem, whatever someone was asking in that class. So consider the mean heap. Mean heap means, as I already told, what is the mean heap means? Mean heap means like at the very first there will be something very small, and after that there will be something large from this. So you can see this mean heap is already given as 15, 27, 33. That means this one is less than this and this. Both should be less than that. I mean, this one should be less than both of them. Okay. And then this is 39, and this is 66. Now it will come here as 15, 27, 33, 39, 66, 39 again.
39 and 47.
Yes, 47, and here it will be 58, and then it will be 51. Now what they are telling, build by repeatedly inserting values into an empty heap. Built, okay, consider the mean heap. This built by repeatedly inserting values into an empty heap. Which of the following could not have been the last element inserted into this heap? So last element into the heap is 51. Which one should, okay, this question maybe we can go a little bit later, because I mean this is nothing but how we can just make the heap. That is the thing they are telling. So if I have at the very first mean 15, then let's say I'm having at the very first 51, then 51 will come at the very last. So this one maybe we can go a little bit last, then maybe we can do this one first, because this is whatever we just right now told. Delete mean twice on the mean heap. So let's say what is the resulting heap. That will be little bit interesting right now. So 13, 29, 24. Then you can see here, this is 67, this is 52, this is 89, this is 45, this is 98, this is 79, and this is 58. Okay. So now there says that suppose we execute delete mean twice on the main heap. So delete mean means at the very first we will just delete the mean. So which one is the mean here? Minimum value. This is the minimum value. So we just want to delete this value. So what will be the structure? The structure should be remain constant by shifting this 58 to 13. So in that next step, what will be the step? Like all the things will be remain same, but 58 will be at the root, and then there is all the other terms are there, 29, 24, and all these things will be there. This, I'm not going to write these values. This, but then there is another one. There is another one. Then this is 50. Okay, now there is no 58. This is 52. But there is no 58 because 58 is it already given here to make the structure intact. But now you can see if it is a mean heap, then obviously this condition is not satisfied, that 58 should be less than 29 and 24. But you can see that this is not true. So what will happen? The maximum of these two will shift. So maximum of these two of 29 and 24 is 29 is maximum. So it will shift here and this will come here. So in the next figure, what will be the answer here? The answer will be here 29 will come, then here it will be 58, then this is 24. And as there is nothing I have changed in this branch, so it will be exactly whatever it was previously. Now coming to 58, and then this one and this one. This one was what? This one was 67, and this one was what was that one? 29, 24, 29, 67, 52. Okay, so this is 52, and these are exactly same. I'm not going to write this thing. So 67, then there is something, and there is nothing. So now you can see these conditions are satisfied. But for this case, 67 is greater than 58. That is good, but 52 is not greater than 58. So it will come. So among these two, which one is the largest one? That will go. So let's say I'm having this one. So 67 will go here and 58 will come here. So for that case, 67 and 58 both are giving the same condition, as well as 67 is greater than. Oh, sorry. What I'm writing? Yeah. Yes. Yes. Just a minute. So for mean one, this one should be largest. This one should be. No.
24 is less, so 24. Oh,
No.
hello, ma'am. Just check. Uh,
No. 13, 29, 24, 67. These things are there. So this one should be greater than this one. So if I just change this 58 to here, and 13 will be removed. So 58, 29. So 29, 24. Both are less. But if I just 24 and 58. Yes, sorry. It should be 24 and 58. So this will be 24 and then. Okay, sorry. Now it is fine. See? Yeah. Yes. So this 58 should come here, not this one. Yes, I made a mistake. Sorry. Not this. Yes. So this will come here, this will come here. So 58 will come here, 24 will go there. So what will be the next step? There it will be 24, there it is 29, which is correct, and this 58 will come. That is correct. And as 29, I am not changing this branch, so that will be exactly intact, whatever it was previously. Okay. Now 58 is there, and for 58, what was there? There is like 89, and it was 24. Sorry, 45. So now you can see 45 and 58. This is a problem. So this will suffer. Not this. If this will suffer, that is enough. So the 24 then 29, then there is all these things. I'm not going to write these things, but this will be like 45, then there will be uh,
89 and 58.
89 and there will be 58. So this is the case. So the answer, I think I didn't write here. Okay, so the answer will be like that. Here at the very first 24, then 29, 45. Then in that case of 29, after that what was 67, 52, the 89.
Ma'am, we need to read it two times.
Sorry.
Please read the question.
Yeah, I mean, we have just did that one only for one times delete mean, but we have to do the another one for the delete mean. But at the very first, just make sure that what was there in the first delete case. So first delete case. So let me write here all these things because it's a very much messy. So it's a very like you can play with these things. It's okay. I can delete this thing. Oh, sorry. Array. Okay, fine. Mhm. So after taking one delete, the structure is 24, 29, 45. Then this is 58. No, 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 no. What was there? I forgot. 29. After that 29, what was there? 29, 67. Shit. I already removed these things. But yeah, fine. Like, just see here. Uh, I think this is 67. It was 67. Okay. Correct. I think this is 67. This is 67.
Yes, ma'am. 67.
Yeah, and
52.
this was 52.
50.
Okay. And here it was 98, and this there is 79. This stream I did not do anything change, and for this case there was something 45. Okay, so for there this case it is 89 and this is 58. Yes, this type of thing is there. Okay, so this type of things is there for only one deal mean, right? But now we will do another deal mean. So what it will be deleted? It will be deleted by this one. I mean, like the 44 will be deleted. So 44 will be deleted means like 79 will come here. So in that case, 79 will come at the very first, then 29, then 45, then 89, then 58, then 67, then 52, and these things are there. One. So now see 79 and 29 and 45. So this is not true here. So if I write here 29 and if I write here 79, so it will satisfy both the conditions. Yes. So let me clear all these things here. Yeah, so it will be like if I just see here, then if I just write here 29, then this will be 79 and then 45, which is fine, and as 45 is unchanged, so all the things will be same. But now here it was 67 and 52,
52.
and there is something now 52 will be replaced by 79, so it will be like 52 and this is 79. So all the things will be like 29, then 52, then 45, then there is something, and then here it is 67. Oh no, one is 67, this is 79,
Yes, ma'am. 67.
and there is something,
79.
there is something. that type of things are there. So this will be the final heap after doing the two delete of me. So just think a little bit that how it is doing. So for the very delete minimum case means at the very first we will just delete from the root, and as we are just deleting from the root, so that means at the very last value will be replaced by this root value, and then we will just check which one will validate the heap structure, which one is violated the heap structure. Accordingly we will do that one. So I just want to have a, yes, this one, this insert case I just want to have, because this insert is little bit different. So you can see here this is the main heap, so that means just quickly do draw the heap here. 25, 42, and always we have to do from top to bottom and left to right, so that's why I'm just writing here this type of branches. 42, then 67, then 38, then 89, then 54, oh, 54, then 98 and 89. So this is the structure. Now they are telling that if I just want to insert 19, so where it should be inserted, it should be inserted here, 19. Yes. So why it should be inserted here, because we are just going to left to right, so left to right it should be filled. So at the very first left will be there, then the middle one, then right will be filled. So if I'm just writing here insert in here 19, then you can see this is not satisfying the condition. So what we can do, we can just swap these things. Like here, okay, maybe I can write it like that. Here it will be 19 and 38. Here it will be 19 and here it will be 38. Now you can see this branch is satisfying our mean heap condition, but 19 is 38. Now coming here, so 19 and 25, this is not satisfying this condition. So this whole is not actually not this whole, these two are satisfying, but this is not satisfying. So what we can do, if I just replace this 19 by 20, 25 and 25 by 19, then both the string branch will be satisfied. So now I'm just writing here 19 and here 25. So now you can see 19 is less than 25, 19 is as well less than 67. So now here also you can see 17 should be less, less than 19, and 17 should be less than 42. Now it is fine. So the final structure will be 17, 19, 42, 67, 25, 89, 54, 98, 89, 38. So that type of structure will be there. Okay. Yeah. So I think you understand this is the main heap case. I don't have the output result here, so if the output result was there, then that would be good. But yeah, fine, like you can see here all the terms are right now satisfying the mean heap condition. 17, 19, 42, 19 is having 67, 25, 67 is having 98, 89, 25 is having 38, 42 is having 89, 54. All the things are fine. Now just tell me these things quickly, because what will be the result for this. If you just can do that one, then we can go for the 8 queen problem in the remaining time. Okay, just do quickly. 13, 29, 24.
Hello, ma'am.
Yes.
We can do it easily. This problem.
Yeah, you can do that one. It's simply no problem with that. So 89, 45. Then there is 98. Then there is 79. And there is 58. So which one will be deleted? 51 will be sorry. At the very first, delete mean. That means 13 will be deleted. So if 13 will be deleted, 50 at the very first, 58 will come. So whole will be deleted. So 58 will be coming here. So for that case, what will be there here? This will be changed. So 24 will come here, 54 will come here. So just do here 24, 58, 24, 58. Now see, 24 is greater than less than 29, 24 is less than greater than, sorry, less than 58. So this whole branch is not affected, so that means this whole branch will be exactly same. But for this case 58, 89 and 45, so it will be changed because this will be swapped. So for this case 45, this will be 58, this will be 45, this will be 45, and this will be 58. So this is the case. So this is for only one delete. Yes. So the another delete will come from where? This will come from here, because you can see this, then there is this whole one set, one line, and there is extra line of these two. So this will be deleted. I mean, this will be deleted and this will be replaced by this. So 79 will be replaced by 24. So just write here 24, and this whole will go. So it will be 12, 79. Yeah. So it will be 79. So if it is 79, then you can see 79 is greater than 29, that is wrong. So 29 will be replaced by 79. So 29 will be replaced by 79. It will be 29, and this is 79. Now you can see 29 is less than 79, 29 is less than 45, that is fine. Now this branch will not be affected, but for this case 79 is greater than 67 as well as 52. So if I just remove this 52 by 79, then that will be done. So 52 and 79. So this is 52 and this is 79. So for this case you can see 52 is very good, then 67, 79, and then 67 is 98. Okay, so this is the result for the double uh, delete min operation. Is it fine? Yes. Yes, fine. Yeah. Okay, so I think I don't have any other question, then we can go for this problem. But before going there, I just want to have one announcement that there is one mail which was coming to all of you maybe, but if it is not taken by you, then I can tell you the what will be the examination mode and what will be the examination thing. So the type of exam will be available in the list. Click here, you can just click this click this link, then you can see our Python course is CBT mode, that means computer based mode. Okay, so for that computer based mode, you can see computer based exam. Please check in the above list corresponding to your course name. The question will be on the computer and the answers will have to be entered on the computer. Type of questions may include multiple choice question, fill in the blanks. As I have already mentioned that one in the previous class as well, that the questions may be include the multiple choice, that means MCQ question. Fill in the blanks, that means there will be something as a fill, you have to write something on this fill in the blanks, or essay type answers. But essay type answer obviously in our Python code it will not be there, but yeah, something related to the programming language it should be there, as I already mentioned in the previous classes as well, that in exam it may be possible that they will say you that you just write one program, short program, but not full program. There's something should be given, and let's say in the last also there is something, but in between that you have to fill this by typing or something. So these things are there. And then on-screen calculator demo link, kindly use the below link to get an idea of how the on-screen calculator will work during the exam. These things are there. Physical calculators are not allowed inside the exam hall, so these things are there. Okay. Yeah. So and another thing is there, I was just mentioning that what will be the difference between tuple dictionary and list, that I will just mention in table form. So I was just making this one, but I did not complete that, so maybe I can just make a difference between tuple dictionary and list in one slide, and I will upload that one in the Google Drive. So no problem on that. Okay, so I think this is for today's thing. Now that 8 queen problem I can write, but the thing is 8 queen problem I don't have right now the documents here. but maybe I can tell you what was the thing they were talking about. Like, what was the thing sir was talking about in that eight queen problem. So eight queen problem is a very interesting problem. So for that case, the main condition for that eight queen is like one queen cannot be attacked by any other queen. So how? I mean, in which possible way we can put n number of queen in matrix. So this is the problem, and the condition is that one queen cannot be attacked by other queen. Okay. So as sir was also mentioning very clearly that if I have more than four, like more than 4 by 4, then only I get 4 by 4 matrix, or more than 4 by 4 matrix, then only I can have a solution for this problem. If I will have less than 4 by 4 matrix, then that will not be solvable for this condition. I mean, there will be not like in 3 by 3 matrix 3 queen can be placed in such a way that everyone cannot be attacked by another two. So this is not the case for 3 by 3. For 2 by 2 as well, it will not be the case. But for 4 by 4, I can have a simply uh, representation so that I can understand one queue cannot be attacked by other queue. So I, so it was like, let's say I am just having one queue here. So one queue means what? The queen in the chessboard. So what is the possible direction one queue can go? It can go this side. It can go this side. That means for row wise it can go, column wise it can go. It can go through diagonal wise also. So you can see this can also be done. So now if let's say I am having one queen in this position. Now all the direction whatever I am just mentioned here, these are blocked by this queen. Now I am just putting the second queen. The second queen may be put here because this is not blocked by this queen. So if I just put the queen here, then you can see the possible direction for this queen is this one, because it can go here like that, it can go this here as well, it can go this like that. But okay, but it can't go this, I mean it can't attack in this line. So for this case we can write here another, let's say another queen. I can put this queen here. So for this queen, this one will be there, the direction, and other no other direction. I mean direction means this direction is also possible, this direction is also possible, but these are twice calculated, we counted, because this is already counted by that blue color. So that's why we are not mentioning here the yellow color here as well, but make sure that this yellow color is not attacking here. This is not the property of Q. So now we can see, if I just want to put a let's say fourth queue. So fourth queen. So fourth queen can be come here. So this is the possible representation of the queen, so that it can fit in a 4 by 4 matrix, and 4 queen can be fit in that 4 by 4 board. So this is the procedure that everyone cannot be attacked by other one. So now you can see, if I just mention here, now go back to the another ink, let's say black. Okay, now you can see, if I am having, it is a 4 by 4 matrix, it is a 4 by 4 board or matrix. So then you can see 0 1 2 3 0 1 2 3. So now this is nothing but 0 0 position, 0 1 position, 0 2 0 3 positions. So by seeing the position of these queens, we can see that each and every queen will be positioned in each column and in each separate row. Means like in the zeroth column you can see only one queen is present, in first column one queen, In second column another queen, in third column another queen. Similarly for row wise calculation, zeroth row there is one queen, for first row there is another, for second row there is another, for third row there is another. So what does this means? This means that the condition, the what I can say, like the thing here that one queen cannot be attacked by another queen. This type of representation will only be possible if or each and every row will be completely filled by one queen, and each and every column as well completed filled by one queen itself at most. Because you can see this, for this queen this is not the attacking position, for this queen this is also not the attacking position, for this also this is not the attacking, for this. So that means as well for this queen this is not the attacking position, this is not the attacking position, this is not the attacking position. Similarly for this is not, this is not, and this is not. So that means what, each and everyone will be independent to each other. So this is the case for 4 by 4 matrix. And if I want to write here 4 queen in a box, the same thing we can make for n by n matrix, n by n board, and n queen in this board, so that everyone cannot be attacked by other people. So this is the question, I mean this is the problem here. So to answer this question, first of all we need to understand one thing, that in one row only one queen will be placed, in one column only one queen will be placed. This is the first condition, right? So that means in the shares program, you can see there was a thing that at the very first Sir was make sure that in one row one queen should be placed, and in the second condition in one column one queen should be placed, and in the third condition, okay, third condition should be what, third condition means diagonally they are attacking, that means the diagonal terms will also be occupied by this queen. So diagonal also we have to take care. So for this diagonal case, Sir was mentioning one thing like L plus I and L minus I like thing. So maybe if you don't understand, then I can go for that one. So the thing is that diagonal conditions, so diagonal conditions will also be there applicable. Okay, so there will be two diagonal condition. So how two diagonal condition will be there? Let's say I'm just writing here only for one queen. Yes, so let's say I'm having yeah, this one. So one diagonal I can see this, another diagonal I can see this. Yes, so we have to represent this type of diagonals in a specific manner, because in Python language Python can't understand that okay, this is our occupied diagonal or this is our occupied diagonal. How we can understand, we can make sure that Python can understand the language or not? So to do that one, we will just make a dependency, we will just make a numbering for these diagonal terms, so that they can understand that okay, this is occupied by this queue, this is occupied by another queue. So for this case, what was the condition here? The condition was like, you know, Sir was already told about these things, that the difference between these two column or two row, that will be same. Like for this case, if I just want to draw this blue line, then you can see see this is column and this is row. So column, if I just want to calculate for this blue diagonal, for this blue diagonal, there is a specific relation between column and row. So you can see, I can write it like here. This is one. Sorry. So if I just see more C minus R. So C minus R means if I will go here, from here to here, I just want to go. So that means in that direction I just want to go. For this case, for this cell, column minus row, that means C0 minus 3, which is minus 3. Now coming for the next cell, this one, I mean 1 minus 2, which is minus 1. No, there should be some relation. 2 minus 1, 3 minus 0, and then this is like 2 minus 1 and 3 minus 0. So there is a specific relation for this diagonal. Similarly, there is a specific relation for this diagonal. There was like one was something j plus 1 or jl I plus 1, something was there. So just making sure that these two diagonal we will talk about, or let's say I'm just wanted to talk about this diagonal. So for this diagonal you can see here 0 minus 2, 1 minus 1, 2 minus 0, this type of things are there, like one specific relation should be there for this case. Similarly, for this diagonal there should be some specific relation. So that means what, in each and every diagonal there should be some specific relation, so that should be interpreted in Python, and then we can make sure that okay, this for this queen we are talking about this direction, this, and then this direction, and then this direction. So no other direction should be occupied by this cube. Now we can see at the very first that row wise problem was already solved, then column wise problem is solved, and then the diagonal problem. So diagonal means this one and this diagonal problem. So these four should be occupied by one cube, and all the other places, wherever the places are empty, there another we can put another cube. So here we can put one cube. So now in that case also we will calculate the same thing, that in that row wise how many occupied space are there, in that column wise how many occupied space are there, now in the diagonal wise how many occupied space are there, and other than these things which one will be the empty one. So this is the procedure for making that program, and then in that program there is nothing but one, at the very first row condition is there, then column condition is there, then diagonal condition. So if we are talking about one cell which is already occupied by this queen, then we will go for the next cell. So this type of things are there. So here you can see this is already occupied, so that means this is empty. So in that empty space there is one queue can be placed. So this you can have a one occupied space, and other occupied space are also there, but as this is a, and also there is a condition to remove the duplicate spaces, because in that case this is also occupied by red one, this is also occupied by the blue one. So we can just remove one, and we can make sure that we are taking only one count for this colored cell. So then we will just go through all the space, and we will have the answer for this case. So this is simply for the 4 by 4 case. I understand this is a little bit like a messy thing, but if I just understand that for the n by n case, that will be a little bit more general, and here how n queens can be placed in that n by n matrix, that is the main question for his lecture. So this is simply a mathematics, not that much mathematics, but the thing is we just make sure that row wise, column wise, and diagonal wise all the boxes should be occupied, so that which one will be the empty one, that one will be occupied by another queen. Then again for this queen, which one is the occupied one we will calculate, and which one will be the empty, that one can be occupied by the third queen. And at the very last, which one will be the super empty space, that will be yes, this one, that will be occupied by the fourth queen. So this is the condition. And here you can see there is only one occupied space and there is no other space left, so that we can't place any other queue here. Only 4 queue can be placed here. Now for the 3 by 3 and 2 by 2 matrix, as I has already explained very well that how we can't put a 3 for 3 by 3, how we can't put 3 queens, or how 2 by 2, or how we can't put 2 queens. But more than 4, if it is greater than 4 or equals to 4, then we can have the example that for any n by n matrix or n by n board, n queen can be placed in such a way that every queen cannot be attacked by another queen. So like the question was this one and the answer is like that. You have to find the way how many blocks are occupied by one queen, and we will go cell wise to find which one is the empty shell, and there we will put another cube. So this is the question and this is the answer for this case. So like this is the procedure as well. And obviously for the programming part, if you just see the programming part, there is a little bit more rigorous thing are there, but the thing is that at the very, I mean, the main thing is that the procedure is to make sure that every attacked position cannot be occupied by any other queue, because let's say if I put another queue here, that is not possible. So this is the main motto for this program. So right now I don't have the program with me, but if you have some particular doubt on particular line in the program, whatever sir was discussing there, then you can tell me, or otherwise maybe I can download that one and after that we can discuss. I don't know that this is right now with me or not. But do you have the specific problem on this problem, like on this specific q queen problem? Yes, q queen problem is little bit general and rigorous problem that I understand, because here we can have a very long discussion, and how to do that in our program, that is also a very long thing. The main thing, we will just make sure we are having a board of n by n matrix, and we will define this matrix in such a way, in such a optimized way, so that we can solve this problem within some 20 or 30 lines program. Then there was a duplicate remove function was there, and then that diagonal numberization, and then row and column numbering is there. So these type of things are there. So yeah, if you have any other doubt regarding this question, you can tell, or we'll see like if there is a very problematic thing, because this type of whole rigorous calculation will not be present in your exam. Okay, I can truly speak that. But yeah, for understanding these things, that is very important, that what is happening here, that should be understandable by everyone. But to write this whole program in your exam, that is not coming in your exam. But you should understand each and every line of this program, that how it is working. So this is the case, just to make sure that,
Hello,
yeah.
ma'am. Can you open Python week 6 assignment
week
for
6
this program?
For this program, there is no week 6 assignment is there, na? Week 6 assignment is not present in that case, right?
Individual lecture, this code is published.
I don't know whether I don't have the access. Maybe let me see, I have the access or not. Mm-hmm. It is not in my, actually I don't have the access right now. Okay, I have the access, but it is not here. Maybe let me see. So just tell me which, in which part you have a doubt, like in that part of the programming itself, right? uh, I mean, in the programming part, you have doubt, like some in the programming line or something, there is some problem which you are facing.
Yes, ma'am, in the line.
Okay, in the programming line. So, which one? Oh, I don't have that one, right? Uh, so how can I have this? I don't have this one in my desktop. Maybe I can have this one in my laptop. Maybe I can open this. Uh, can you tell me? I mean, I think in that week 6 quiz there is no problem, because in week 6 quiz there is no programming assignment. But obviously, if you want to know this program, that is very good. But in a week 6 quiz there is no problem, right? Because this is only four
Yes, ma'am.
questions. Yeah, there is only 4 questions. But I don't know right now. I don't have the access to open this. I have the access to open in my laptop. But let's see. Um, where it is. I don't have that one here. Okay, which line you are talking? Can you tell me which line you are talking about? Uh,
Line 5.
okay. What is that line basically? Because I don't right now have that one.
Board the in a square bracket row.
Array, it is not opening. Yeah. In the first lecture you are talking.
Yes, ma'am.
Okay, let me open this one. It is opening. Mm. Yeah, so you can, I think, yeah, you can see this thing. This you are talking, right? This slide you are talking.
No, ma'am. In a first lecture, you can see in a n Python n queen problem
Yeah,
and open it.
yeah, input problem is there. So there is program as well, but the program is, I think, at the very last. Let me see. Actually, whatever you people can see, most of the things I can't see actually. Yeah. So, 8 colon. Yeah, so coding the solution, overall structure you are talking. 1, 2, 3, 4, 5. No, not 5. Where is the full? Mhm. Overall structure, all solutions. Ready. Okay, so right now I think I don't have that one. So what is the line basically you are having problem? Hello?
Why we assign -1 for this?
Why we are assigning -1? Hello? -1? What problem has it there? Which one you are talking about -1? That
Line 5.
attack ij equals to -1. Okay, maybe I can't see that one right now. Mhm. See, the attack is like, okay, maybe I can think that you are talking about this one. If I am right, you are talking about this one. Ij is attack if it is row is attacked, then column J is attacked, and then diagonal J minus 1 is attacked, and then again diagonal J plus 1 is attacked. This line you are talking, so these four conditions should be there for IJ is attacking. Okay, so this one is nothing but as we were seeing there, that this is I, let's say J, so this should be attacked, this should be attacked, and this one and this one. So this one is nothing but 1J plus 1, yeah, and this one is J minus 1. So this whole attacking position, we can make sure that this whole four thing will be attacked by this IJ column. And minus 1 is nothing but, minus 1 means it will return as this is not attacking. That means, okay, so here you can see, yes, for this case, for the blue line, you can see this, that blue lines are attacking position. But for this case, this position, which is 2-2 position, 2-2 position is not attacking position. So whenever we will go for the first queen, for this 2-2 position, it will return I, J as minus 1. Minus 1 means it is attacking free. It is not attacked by this queen. Okay, and here as well it is like 1-3. 1-3 position is attacked, it is not attacked by this like q. So the second q can be placed in that minus 1, I mean when ij will counted, and when for this first case, when we will see that 1-3 position is not attacked by this blue q, then at this position red q will can be placed. Now for this red q, we will again calculate all these things, that j plus 1, j minus 1, row I and j. For this case, you can see that 2-2 position will give us a minus 1 value. Minus 1 value for this red one. That means for red one, 2-2 is not a at, oh no, for red one, sorry, for red one, this one will be, or this one will be, what is that, 2-0. 2-0 position will give a minus 1 value. Now for uh, yellow one, so that means whenever the minus 1 will come at the ij index, whenever it will come as minus 1, that means it is attack free. So that means here I can put one queen. So for this case, for the yellow case, if I just put the yellow here, then I can see for the yellow hold the space, but I can only found that 3-2 position is my giving us minus 1. So that means for q, there is only one value left which is not attacked, and that value is 3-2. So for this case, we can have another q here. So minus 1 is very important. Ij is minus 1 means what? That means that it is attack free. So whenever it will return as attack free, that means we can put one q, new q in that position. So sir was mentioning about 8 by 8 matrix. So it was like 0 to 7, 0 to 7. So there you can see, if ij is minus 1, then only we can put another new q at this position. So at the very first, we will scan for one, putting one q, one in that one ij position, and then we will scan how many possible attack positions should be there. Then which one will go as a minus 1. In that position, we will put another new q. So again, we will scan this, and whenever we will get a ij equals to minus 1, then we can put another q. So like that, he was mentioning the program, as you can see there is a, for 7 by 7 like 8q problem, there is total 8q can be placed in such a way that everyone cannot be attacked by other one. 1 2 3 4 5 6 7, no, so there is only a possible calculation here. uh, okay, I don't have the programming right now, but the main thing, as you were saying, what is the meaning of minus 1, sorry, ij minus 1, this is nothing but attack free position. Whenever you will have ij minus 1, then only you can insert one q. So if you just run the program whatever server is having, then you can see that there was 0 0 position, then 1 7 position or something like that. So that means at this position there is one queue, at this position there is another queue. So how it is coming? It is coming with the sense that whenever ij equals to minus 1, for this case another new queue is coming in that position. So I think it's fine. Just make sure to answer, read the program again. Okay, and if you have any further doubt, then we can talk in mail as well, so that we can answer that one.
Okay, ma'am.
Yeah, so just mail me if you have any doubt, because I don't right now have the program with my hand right now. So if you have any problem, then you can just mail me here. I think you have the mail id, but still I'm just writing here.
Yes, email ID.
Yeah, you have that one. Okay, fine. So yeah, okay then, tata. Because like as I don't have right now the programming with me, so I can't say in which line you are having exactly the problem. So you can just mail me with that program line, so that this line have the problem with me, this line have the problem, I don't understand this line, so that means we can just discuss that one by mail as well. Okay, so okay then, today we can stop our meeting. We'll meet in the next class. Okay,
Okay, thank you, ma'am.
bye. Yeah.